Hello and welcome back to Global Math Mentor. This is another lesson on quadratics and additional mathematics, and today we're diving into an important concept, the discriminant. It's written over here, you can see. Understand how the discriminant relates to the roots of the equation, and not just any equation, the quadratic equation. So we know a standard quadratic equation looks something like this. And remember, there was a formula used to find the roots of a quadratic equation, which is b squared minus 4ac and divided by 2a. Okay. So what is discriminant? This thing inside, this expression inside the square root has a name, Mr. Discriminant, right? Okay, so uh, I'll break down with simple explanations and go over some examples step by step so you can understand exactly how and when to use it and how does a discriminant helps us find the nature of roots of a quadratic equation. All right. So quickly take a look at the syllabus 2.3. Know the conditions for fx equals to 0 have. So you can either have two real roots, two equal roots, or no real roots, right? So I'll talk about the rest of the things in the later part of the video, right? Okay, let's dive into these three examples and quickly take a look at it. How do we find the nature of roots? So by nature of roots, like either they are both equal, both distinct, or not equal, or imaginary or complex. Okay. So what is the nature of roots of the equation? This question one. So you can just check the discriminant value, which is b squared minus 4ac. And that's 36 minus a 36. That is type 1, 0. So when you have a 0 discriminant, take your notes. When b squared minus 4ac is equal to 0, you will always have two real and equal roots. So you can either say equal or repeated or same. It's up to you. But we'll discuss how the graph of this equation looks like in the next part, right? Determine the nature of roots for equation this, the second equation, right? This is the first one. So I'm going to solve the second one now. B squared, B is a 7, minus 4AC. A is 2, and C is a 5. So what do you get? 49 minus. So it's 8 fives are 40. Oh, this is a positive value, greater than 0. You can write the second condition. Whenever b squared minus 4ac, the discriminant's value is greater than 0, you will have two real and distinct roots. So by distinct, we mean they are different, both of them. We'll get to those, like how does the sketch of this graph looks like. Okay, last part, this third one. Check the nature of roots of a quadratic equation in this case. So b squared minus 4a and c. Okay, now let's find the value. 16 minus is going to be 40 and 12, 52. So, oh, that's a less than 0 value. So I'm not even calculating, but I know it's less than 0. All I need to tell is the nature of roots. So that's the third part. Let me just write over here. Whenever b squared minus 4ac has a negative value, you will have no real roots. There are other ways in which you can express this, like complex roots. So this is like you will study the complex numbers in later part in the A levels and even beyond. So right now you're not familiar with the word complex, so you can use imaginary right now. Imaginary roots. All right. Let's take a look at these examples once again, but with a different perspective. Okay. So I'm going to sketch each of these equations, and then we can find the relation, like how the discriminant relates to the sketch of a parabola. Okay. So the first one, it's x squared minus 6x plus 9. So if you try to factorize it, it's going to be x minus 3 whole squared. Okay. So we know that the only root it has is 3, since each of the factor is x minus 3 and x minus 3. Now I'm going to show you the sketch of this parabola. This will look like 3, 0 is the vertex of this graph, and it will go something like this and this. Okay, y, x. So what do you observe? Like you can think, if you want to write this value over here as well, this is 0, 9. That is the sketch of this first part. Can you notice what's the key feature in this case? Okay, so you can take notes on that as well. When roots are equal, the x-axis is tangent to the curve. Now we take a look at this problem too. So I'm going to check the sketch and try to find a connection, like when the discriminant is a certain value, how does the sketch of this quadratic curve looks like? So earlier I found out that the discriminant in question 2 is a positive value. So you'll see that I'm going to factorize it quickly to check what kind of roots it has. Obviously, it has 2 distinct roots, 2x, x plus 1, and plus 5, x plus 1, which is 2x plus 5 and x plus 1. Okay. So one of the solutions is a negative 5 over 2. The other is a negative 1. So this is also worth noting, another key feature of parabolas, that roots are actually the x-intercepts. And it's not just the case with the parabola. All across the functions, whenever any function, a linear, a quadratic, or a cubic, or any degree or a trigonometric, if it intersects the x-axis, it has a solution, right? So I can use the x-intercepts or the solutions to sketch my parabola, which will look something like this. And this is a 0 and a 5, okay? I'm not interested in the vertex right now. So what's the key feature? Can you guess? Okay, take notes on that as well. When b squared minus 4ac is greater than 0, the graph intersects, or you can say the parabola intersects the x-axis at 2 distinct points. So you can rewind this and check again why the parabola in the first part was tangent to the x-axis. I'm repeating it again. Reason, whenever you have equal roots, the x-axis is tangent. When you have distinct roots, the x-axis, we have 2 x-intercepts. The graph intersects the x-axis at 2 distinct points, right? Okay, now we take a look at the sketch of this problem 3. We already established that the roots are imaginary in this case, but I want to take a look at the sketch. So since I cannot factorize it, I'm just quickly completing the square to get the vertex, and I can use my vertex to sketch this quadratic expression, x plus 2 whole squared. And this will be 13 minus a 4, which is a positive 9. So I've got the vertex, which is negative 2 and a 9. Let's sketch it and see how does it behave. Okay, so a negative 2 and a 9 is here somewhere. It's just a sketch, guys. It will look like this, right? So what do you observe? Okay, take your notes. When b squared minus 4ac is less than 0, the curve is entirely above, maybe sometimes below the x-axis. Okay? Or you can say that does not meet the x-axis. Okay, I can say that as well. Does not touch or meet the x-axis. Okay, let me just quickly summarize. So case 1, discriminant is 0. Then the x-axis is tangent to the curve. Number 2, Keep noting, when the discriminant is a positive value, you have two distinct x-intercepts. Number three, when the discriminant has a negative value, you have no x-intercepts, means no solutions. Since the places where the graph crosses or touches the x-axis gives you the solution. If it doesn't touch the x-axis, it has no solution. Now that you've seen how the discriminant helps us determine the nature of roots of a quadratic equation and how that connects visually to the graph of a parabola. For example, if b squared minus 4ac is equal to 0, then you have either this situation or this situation, right? Depending on the value. This is when a is greater than 0, and this is when a is less than 0. That's your first bullet. And when b squared minus 4ac is greater than 0, then you have a situation like this. The graph intersects, let me just mark, these are the x-axis. X-axis at two distinct points like this, or maybe the upside down parabola, depending on the value of a. And last, b squared minus 4ac, if it is less than 0, then your curve is either entirely above or entirely below the x-axis, right? Depending on a greater than 0 and a less than 0. So that was the summary of this lesson. In the next part of the series, we'll flip the script. Instead of finding the nature of roots from the given equation, we will use information about roots, like whether they are real, equal, or imaginary, to find missing values in quadratic expressions. This is where things get even more interesting. You'll begin to solve for unknown coefficients and find range of values that guarantee certain types of solutions. Stay tuned, because understanding how the discriminant behaves gives you a powerful control over the equations you work with. All right, over and out.